So welcome back to the second part of Trig Notes 3.1, Law of Sines. In the last video we talked about when we have to check for the possibility of two different triangles occurring. And that occurred when we were given one angle, like in this example here, but that one angle had to be an acute angle. This one is not, so I'm not going to have the possibility of having two different triangles here because I can't have another angle in my triangle that's more than 90 degrees, because then I go over 180 altogether. So I don't have to check. So let's go through and label what we know. We have this angle side opposite relationship, so we'll use the law of sines. Before I actually start that, let's list what we need to find. We need to find angle B and angle C and side B. So take the sine of 100, divide it by 125, and set that equal then to, because you know side C, you have to find angle C first. Sine of C over 10. Okay, so let's cross multiply to solve this. 10 sine of 100 equals 125 sine of C. I want to get the C by itself, so first I have to get rid of the 125. I'll do that by dividing. Typing this in my calculator, 10 sine of 100 divided by 125 gives me 0.07878, and it keeps going on. But that's what the sine of C is. I don't want the sine of C, I just want the C, so I move the sine over by taking the inverse. I'm going to get 4.5 for C. So angle C equals 4.5 degrees. Now that you know C, you can find B pretty easily by saying angle B should be equal to 180 minus the 100 that you already know and the 4.5 that you just found. So you're going to get B to be 75.5. And now you can find side B by setting up another proportion here. We'll use the sine of 100 over 125. Again, I'm using that because that's what I was given. Neither one of these are rounded answers. Set it equal then to the sine of 75.5 over B. Cross multiply. We'd have to get rid of the sine of 100 by dividing. So 12.5 sine of 75.5 divided by the sine of 100. I get 12 point, I round it 3. I just realized that I made a mistake here. This wasn't 12.5, this is 125. So let me go back here. Thought that side angle, or that side length looked a little funny. Let me recalculate that one more time. It's 125 sine of 75.5 divided by sine of 100. There we go, 122.9. Always stop and ask yourself, is my largest angle across from my largest side? Well, angle A and side A are the largest, angle B and side B are the second largest, and C and side C are the smallest. So here would be my three answers. Looking at the next example, I'm given one angle, and that angle happens to be acute, so this is where I have to check for the two triangles. Ask myself, is this an example where I could possibly have two different triangles? Yes, it is, so I've got to check. So finish labeling what you know. Let's list over here what we need to find. We need to find angle B and angle C, and we need to find side C. Again, because this is an acute angle, I'm only given one angle, I've got to check to make sure that there isn't two triangles, or maybe that there are two triangles. So first we'll start off with the sine of 58 over 4.5. And because we're given B, we have to do then the sine of B next. So cross multiply. Cross multiply. Divide by 4.5. Would get 12.8 sine of 58 divided by 4.5, which would be 2.4, 2.412 as the sine of b. But I don't want the sine of b, I just want b, so I have to move the sine over by taking the inverse. Now when I do this, I end up getting a domain error in my calculator. And the reason for that is because the sine value, the inverse of the sine value, remember we talked in previous lessons, can only be between 1 and -1. So if you're trying to take the sine of an angle, or you're trying to find an angle that has a sine of 2.4, there is no angle that has that. So this leads us to our third type of triangle that we could have, and that is a triangle that does not exist at all. So this would be a no solution. So now we have to keep in mind that we may have one triangle that could exist. We may have possibility of two different triangles that could exist if we're given one acute angle. Or, depending on the information that we have, we will not have a triangle that has this given information. So we could have no triangles that could occur. And your calculator will tell you when the no triangles will occur because you're going to get that error. Alright, let's shift gears here a little bit and let's move away from finding missing sides and angles. And talk about finding areas of an oblique triangle. So again, this is the area of a non-right triangle. We're used to using this formula, 1/2 base times height, but again, that's typically for a right triangle where we know vertical height and a base. So instead, I'm going to introduce to you 3 different formulas. They all look very similar. They all say half, then they all say 2 side lengths, and then they all say the sine of one of the angles. So what you need to do first is draw the diagram and then figure out which one of these you will use to find the area. So let's just draw a triangle. It says it has side lengths of 90 and 52, and the included angle is 102. So the angle in between the two sides you just drew is 102 degrees. So let's go through now and label it. These would be my angles. Let's say A, B, and C, which would mean that this would be side C, this would be side A, this would be side B. And you can do that however you want. That will just then depend on which one of the 3 you use. Because I know angle B, I have to use this middle one, that the area is equal to half of AC times the sine of B. So let's plug in what I know. Half of 52 times 90 times the sine of 102. So typing this into my calculator, I end up with 2,288.9, and we were told meters was our units, meters squared. So this triangle will have an area of 2,288.9 meters squared.